Hey guys, it's Mr. Gottlieb again. Welcome to Unit 9, Day 9, Reciprocal Functions. So today we're going to be talking about secant, cosecant, and cotangent. But before we do that, I just wanted to do a little bit of a refresher on the regular functions, SOHCAHTOA, sine, cosine, and tangent. So we're just going to pick one to do. We're going to do two examples together, and then you guys are going to try the rest on your own. And then we're going to go to cosecant, secant, and cosecant, secant, and cotangent to look at the reciprocal functions. I'm just going to pick two, so I'm going to pick tangent of 305. So the tangent of 305, it's between 0 and 360, so we don't need to find a coterminal angle. We do need to know what quadrant that's in. 305 degrees should go past 270, so if we were to rotate around, this would be 90, 180, 270, so it's somewhere over here. So this is our angle. Let me draw it another color. The reference angle is the angle formed by the x-axis and the terminal side. So this is our reference angle. Put a little r in there. Now, if this angle on the outside is 305, the angle on the inside is 45. So we have a 45-degree reference angle. Now, the steps. We have to know that all students take calculus to know that tangent is not positive in quadrant 4. Cosine is positive in quadrant 4. So that means we can replace tan of 305 with negative tangent of the reference angle, which was 45. And then we're just going to calculate tangent of 45. So tangent of 45, according to our table, if I were to just scroll up here, tangent of 45 is 1. So I should get negative 1. So if I just use my calculator, which you can do, you can use your calculator for all of these things. If I just type tangent of 45, I will get 1. So it's negative 1 because we're using 305. So if I do tangent of 305, it should say negative 1. Oh, wait. Oh, the reason I'm wrong here is because my reference angle is not 45. The reference angle is actually 55. So this is actually 55. So let's go back here. So this would be negative the tangent of 55 degrees. Now 55 is not on our list. So if I do tangent of 55, I actually will get a decimal. It's the same as 305, except it's positive because 55 is in quadrant 1, and quadrant 1 everything is positive. But because tangent is negative in quadrant 4, 305 gave us negative 1.428. Now, unlike all those nicer numbers like 0, 30, 45, 60, 90, and all the multiples of 90, we don't actually have nice values that we can represent with radicals and fractions for these other infinitely many different degrees for our angle. So in this case, we're actually going to have to write the decimal. So the tangent of 305 is actually negative 1.428. Please be careful. If you do get a nice reference angle, you would use the radical expression. So let's try and get another one that has a radical expression for it. So let's say we were to do sine of 480. Now this one is not between 360 and 0, so we're going to just subtract 360 to find a coterminal angle. That's on 120. If we were to look at the sketch, we draw 120 degrees is over here. So this is 120, but our reference angle, again, is formed by the terminal side and the x-axis. So our reference angle is here. Now, if this is 120, then our reference angle is 60 degrees. And we also need to know that all students take calculus. So sine is positive in quadrant 2. So we're going to write positive sine of 60. And if we look at our table of values, we get the sine of 60 is equal to radical 3 over 2. Let me just check that just to be safe. Sine of 60 is radical 3 over 2, which is 0.866 in a calculator. So if I do sine of 480, we get 0.866. If I do sine of 60, I get 0.866. If I did the 60-degree angle in this quadrant, that would be the same thing as, it would get a negative number. That would be 180 plus 60, or 240. So if I did sine of 240, I should get negative radical 3 over 2. All right, so you're going to have to try the rest of these on your own. You could just use a calculator. So if I just, let's just do one more together. So let's just do cosine of 570 with a calculator. Cosine of 570, I get 0.866, and it's negative, so my answer is negative radical 3 over 2. That's the easy way to do it, but that only worked out because 570's reference angle is one of those nicer numbers. So if we do minus 360, that'll be 210 on the axes. 210 is in quadrant 3. Our reference angle is made with the x-axis and our terminal side. So this is a 30-degree reference angle, which is why this worked out the way it was. And by all students take calculus, cosine is not positive in quadrant 3. So we could have written this as negative cosine of 30 degrees. But yeah, we did this with a calculator without doing any of the other work, but I would appreciate if you have the work when you're at least writing your notes. You can use the shortcuts, and once again, the reason this one is a decimal is because 55 is not on our list of nice values or common angles. Let's take a look at what to do for the reciprocal functions. So you'll see I still have the same list up above. The only difference between the problems we're doing now and the ones we were doing before is we're using the reciprocal functions. So let's take a look at the examples. Just go in order for a few. For secant, we need to remember that secant is 1 over cosine. So pretty much whatever we would have done for cosine, we just flip over to get secant. So for 0 degrees, looking at our graph, as we might remember from yesterday's lesson, we're doing 0 degrees, which is over here. The coordinate here is 1, 0. That's our x and y, and we also know that x is cosine of the angle and y is sine. So for secant of 0, it means we take our answer for cosine of 0, which is 1, according to the x value being 1, and then we take its reciprocal. So secant of 0 should be equal to taking 1 over 1 and flipping it over. We still get 1, so the secant of 0 is 1. On a calculator, that would be 1 divided by cosine of 1. And that's weird, it gave me something strange. 1 divided by cosine of 1. Wow. Is my calculator in the correct mode? It's in degree mode. Not sure why that's happening. It's a strange scenario that came up there. Cosine of 0. Oh, I did 1. Cosine of 0 is 1. 1 over cosine of 0 should also equal 1. All right, so the same thing would happen for 90 degrees, just different angle. 630, 270. A lot of these are multiples of 90. So let's do one for 420. So 420, if I want to bring that between 0 and 360, I'm going to have to subtract 360. So that should leave us with 120. So that's our coterminal angle. So let's draw our angle. 120 is in quadrant 2 here. The reference angle is formed with the x-axis and the terminal side. This is our reference angle. If this is 120, then the reference angle is 60. All right, so let's find so secant's the reciprocal of cosine, so let's find the cosine of 60. Oh no, that's not correct. The cosine of 120 is going to be equal to the negative cosine of 60, because cosine is negative in this quadrant. So that's negative 1/2. So if I do cosine of 420, I should get negative a half. Oh, it's positive a half. Cosine's positive. And wait, hold on. 420 minus 360 is 60. Oh, I made an error before. The reference angle is not 120, it was 60. So on my diagram, let me erase this part. I'll erase this whole one. So we're just going to redo problem 17 real quick. So if we subtract 360, we get 60. So our coterminal angle is actually 60 degrees, which is over here. All right, so our reference angle is also 60 degrees. So this is our reference angle and our coterminal angle at the same time. So we're going to look at cosine of 420 because that's the reciprocal of secant. That's going to be equal to positive cosine of 60 because cosine is positive in quadrant 1 because all students take calculus. So cosine is one of the all. So that's positive. The cosine of 60 is a half. And then to find the reciprocal, we flip that over. So the secant of 420 should be equal to 1/2 flipped over, which is 2. So if I do 1 divided by cosine of 420, I should get 2, which I did. Try the rest of the problems on your own. If you have any questions or if anything was confusing, I acknowledge I made a big mistake on number 17 by subtracting without using a calculator to check my work. But you can do all of these things again by hand, just like you would with the other ones. Let's just do one more. Actually, let's do cotangent of 390. So I know that's 1 over tangent of 390 on my calculator. 1 divided by tangent of 390 is equal to 1.732, which, according to the list of values, is radical 3. So this is the same thing as radical 3, which we can go through the whole process we did a minute ago by drawing our angle and then doing tangent and then flipping it over. You know what, let's do that. Let's do that. So we have 390 is just 360, so full rotation and another 30 degrees. So that's a 30-degree reference angle. The tangent of 30 from our table should be equal to radical 3 over 3. Then to find the cotangent of 30, or the reciprocal of that, so the cotangent, so that would be, so yeah, it would be the positive tangent of 30, because we're in quadrant 1 and tangent's positive there. We should get radical 3 over 3 from our table. So the cotangent of 390 should just be equal to the reciprocal of that. So the sign isn't going to change, so it's still going to be positive, but it'll become 1 over radical 3, because that is radical 3, oh, it's 3 over radical 3, excuse me. So that should be not 1 radical 3, but 3 over radical 3. We can't leave our final answer that way, so what we're going to do is we're going to multiply the top and bottom by radical 3, because you can't have a radical in your denominator. The 3 radical 3 in the numerator will stay, and the denominator will become 3, and the 3's will cancel out, leaving us with radical 3. So we can do it really fast with a calculator, if you know your decimals. If not, you have to go through the process of finding the tangent of the reference angle and giving it the appropriate sign, and then performing the reciprocal. Hopefully this was clear. If you need anything, ask me on Google Classroom, and I'll help you to the best of my ability.